host planetary systems, and one of those
Yes.
stars is our own sun. Revolving around the sun are 8 planets. The planets are divided into 2 categories based on their composition:
That's the
terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life.
You know how to spell environment?
Yeah. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense.
Is it Jupiter?
The largest Jovian is also the largest planet in the solar system.
Learned about that.
Jupiter.
You was a kid.
Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system, since that is where the gravitational and physical influences of the sun end. Our solar system's particular configuration of planets and other celestial objects, all revolving around a life-giving star, make it a special place to call home.
That was fun, Papa Greg.
See, that's all the planets. That's what you just have there.
The Neptune? The Journey?
Yeah, that's 2 hours. That's too long.
Our solar system is larger than you think, and the amount of time it takes to escape it will shock you. Take a look at the size difference between planets and moons that call our sun home. The size difference does not become apparent until we reach the gas giants, and even those giants get dwarfed by the sun. Displaying these planets so close together does not represent how wide the solar system actually is. These planets stretch so far apart, to display the distances accurately, we must shrink the planets down to a point. The distance between the Sun and Neptune is 4.5 billion kilometers, but this is not the end of our solar system. The edge of our solar system is called the heliopause, the area in which the Sun's magnetic field ends. This boundary is 18 billion kilometers away from the Sun. The fastest spacecraft to pass this boundary to date was Voyager 1, which left Earth in 1977 and escaped our solar system 35 years later in 2012.
You want me to get it?
Yeah.
Our solar system is larger.
Earthquake?
Earthquake when we shook. TH.
What's the next word?
Quake.
How do you spell that?
Earthquake. Q.
Go ahead.
Mary, how do you spell earthquake? He's searching it up. How do you spell earthquake?
Birth injury cases are unique because of the gravity and the unexpected nature of the injury.
Where's your at?
What is an earthquake? Would you be surprised to learn that several million earthquakes happen every year? Seriously, most are so small in magnitude or size that we cannot even feel them. In fact, only 20 earthquakes are officially reported each year in the United States Geological Survey. Wow, that is a huge difference. The Earth has 4 major layers: inner core, outer core, mantle, and crust. Think of the crust and top of the mantle like the skin of the Earth. This skin is made up of different pieces of rock called tectonic plates. There are about 15 major slabs that join together, kind of like a puzzle. The edges around the tectonic plates are called plate boundaries. These massive pieces of rock slide back and forth under the Earth's surface, bumping up against each other and creating a lot of tension. This tension and movement create faults, which are basically huge cracks in the rock. When the faults get stuck, they build up pressure. And when they get unstuck, you guessed it, an earthquake. So basically, an earthquake is caused by the shifting and sliding of tectonic plates on the Earth's upper mantle and crust. There are 3 ways that tectonic plates shift or slide. They are subduction, lateral sliding, and spreading. Subduction happens when plates crash into each other. This can cause one plate to slide under another and be destroyed. Or the edges of the plate may rise up and form mountains. Lateral sliding means that the plates slide alongside each other, which can create lots of friction. And like you might have guessed, spreading happens when plates move apart from each other. When they do, melted rock between the plates rises and cools, forming new crust. Here's an interesting fact. Nearly 90% of all earthquakes begin in the Pacific Ocean, in an area called the Ring of Fire. It's called the Ring of Fire because along with earthquakes, it's filled with many active volcanoes, more than 450. Earthquakes can be powerful enough to change the surface of the Earth and can do a lot of damage. And sometimes, earthquakes can even cause other natural disasters, like avalanches, landslides, and tsunamis. Pretty wild, right? The epicenter is the location of an earthquake on the Earth's surface. The closer you are to the epicenter, the more of the earthquake you will feel. Earthquakes lose intensity as they travel
Did you learn about
away
earthquakes
from the
when you was a
epicenter.
kid?
Scientists measure the intensity of an earthquake
You learn about
using a special
Martin
device
Luther
called
King?
a seismograph. Seismometers detect and measure the vibrations given off by an earthquake. Magnitude is the number given
Put the ball
to
away,
record
come back
the
and sit on
size
the
of an
couch.
earthquake. For example, a magnitude 5.5
Where
is
should I put
considered
it?
moderate. Above 8.0 is considered a major earthquake, and we see one every
Are you
year or
listening to
two.
the words?
Earthquakes measured at 2.5 or less are usually not felt, but can be recorded. And believe it or not, there are millions that happen each year. You can make a model of a seismograph at home, and we are going to show you how. It's activity time. You can print off directions for this one on our website at learnbright.org. You'll need a cardboard box, string, a plastic cup, a marker, small heavy objects, a long strip of paper, and a friend, because this is an activity for at least 2 people. Now comes the fun part. One
Look.
friend shakes the box,
Have you seen
alternating
it
between
before?
hard and soft, and slow and fast,
Yes, you
while
have.
the other friend is pulling the strip of paper through the bottom. Watch the marker as it records.
What?
Have you seen it in real life before?
An earthquake?
Have you seen it
I have felt one, yes.
when you was little?
No, when I was big.
The movement. This is exactly what a seismograph does during an earthquake. So, in a way, we have not only created our own seismograph, but our own earthquake as well. Now, we can analyze the data just like scientists. Can you tell how hard the box was shaking based on the line? Can you tell when it was barely shaking at all? You are on your way to becoming a seismologist. A seismologist is a person that studies earthquakes. It's pretty cool to watch the process, but it's even more exciting to do it yourself. You can head on over to our website to get detailed instructions for this activity. Just download the lesson plan, and as always, have fun.
National Day.
Okay. Earthquakes and tsunami. This is what you want to watch. Tsunami's real bad.
Let's learn about earthquakes and tsunamis. If you feel the earth moving under your feet, it could be because a man is barreling by, or maybe you're at a ripping concert, or maybe it's
Is it
because you're
under?
experiencing an earthquake. Call it whatever you like,
What?
a
Is it
quake,
under?
or a trembler, or a tremor. It can be unpredictable, and it can be very scary when the earth begins to shake. When a vibration travels through the earth's crust, this is an earthquake. They happen somewhere on the earth every day. Here is what may be happening as geoscientists seek to explain what causes earthquakes. The outer layer of the earth is called the crust. The crust sits on many different layers that rests upon ginormous plates which cover the earth. Beneath these tectonic plates, deep down in the bowels of the earth, are areas of molten rock and metals. The tectonic plates drift and move, and not much, but it's enough to cause the earth's crust to fracture and create faults and folds. The faults in the earth create humongous pressures, and the crust begins to slip and heave and throw.